Hello friends, in this video we are going to discuss about the operation of NMOS in the triode region. As we know that for the NMOS there are two different regions of operation in the drain characteristics. The first one is the triode region, that is the ohmic region where the drain current increases linearly with the drain to source voltage, and another one is the saturation region where the drain currents remains constant for the increase of VDS. In both the cases the gate to source voltage is kept fixed. Now let us see what will happen or what are the conditions that should be achieved during the triode region. So equation of NMOS in triode region. So in triode region it is also called as ohmic region or linear region. In ohmic region the condition is given by that the drain to source voltage, that is VDS, should be smaller than the VDS saturation. Means we can write that the VDS is smaller than the VGS minus VT. This VT is the threshold voltage. So we can say in another way that VDS should be smaller than VGS minus VT, and in this equation the value of VT is very small, so we can neglect this threshold voltage VT and we can write that drain to source voltage is less than the gate to source voltage, or we can say in a short form that drain voltage VD is less than the gate voltage. So this is the condition for the triode region, and in this triode region we will get a current which will linearly increase with the VD. Now in this triode region let us see what will be the equation of current ID. The ID current in this triode region is given by the equation ID equals to mu n into COX, where COX is the oxide capacitance, and into divided by W by L, that is the aspect ratio of the NMOS, into VGS minus VT into VDS minus VDS square divided by 2. This ID equation can be derived from the analysis of the NMOS in the triode region, but for the GATE syllabus and the GATE questions, the derivation should not be required, only the conclusion is required, so I have taken the conclusion. So in the triode region exist for very small value of VDS, so we can say triode region of NMOS exist for small value of VDS, that is the drain to source voltage, so we can neglect the term VDS square divided by 2, because VDS is a very small value and VDS square will also be a very small value. So neglecting the term VDS square by 2, we can write the equation of ID in this manner, that it will be equals to mu n into COX into W by L VGS minus VT into VDS. So this will be the equation of ID in the triode region by neglecting the VDS square by 2 term. Now, if I take this mu n into COX constant, because it will be a constant value, so I am terming as Kn. So this Kn is a process transconductance parameter of NMOS transistor, and the unit is ampere per volt square. Now if I replace this Kn value in the ID equation, we will get ID equals to Kn W by L into VGS minus VT into VDS. Now if I look at these two terms, Kn into W by L, that is Kn into aspect ratio, let us take a new constant Kn dash. So it is a value of new constant. So I can write the equation in this manner of ID as ID equals to nearly equals to Kn dash into VGS minus threshold voltage Vt into drain to source voltage. So this is the equation for the drain current in the triode region or the ohmic region. From this equation we can see that ID is a function of gate to source voltage and drain to source voltage. From this ID equation we can derive some parameters of the NMOS in the triode region. The first parameter that we can derive is the drain to source resistance, that is equals to R suffix ds. So let us find drain to source resistance, and this RDS is defined by the equation voltage drain to source divided by ID. So this equation will give the value of RDS in ohm, and this RDS is also called as the channel resistance of the NMOS. Now if I find the value of VDS by ID from the ID equation, then I can write this RDS value as 1 by divide Kn dash into VGS minus VT. So this equation will give the value of drain to source resistance in ohm. So we can see that the characteristic resistance or the channel resistance RDS can be altered by applying the gate to source voltage, that is the channel resistance RDS can be altered by altering gate to source voltage, and in the triode region a NMOS can be used as a voltage control resistor where the channel resistance can be controlled by the gate to source voltage. The second parameter that can be found in the triode region, the transconductance denoted by G suffix m. By definition, the transconductance is defined by del ID by del of VGS. That means rate of change of ID divided by change of VGS, because we have now discussed that ID value is a function of VGS and VDS. So, if I keep VDS constant and if I change the value of gate to source voltage from some value to another value, then ID value will change from initial value to final value. So, change in the ID due to the change in the gate to source voltage at constant VDS is termed as the transconductance of the NMOS. And if I do find the ID by del VGS from the ID equation in the triode region, because we know the equation of ID in the triode region, then del ID by del VGS will come as Kn dash into VDS. So, this equation will give the value of the transconductance in the triode region. So, we can write the Gm value is equals to Kn dash into VDS in mho. So, in this way we can find the value of the transconductance in the triode region. Similarly, we can find the value of the output conductance GD. So, this is the third parameter that can be defined from the ID equation in the triode region. So, the third parameter is the output conductance. It is denoted by GD, or it is also called the drain conductance. So, GD is defined by del ID by del VDS in mho, and we know that ID is equals to Kn dash into VGS minus VT into VDS. So, if I find the value of del ID by del VDS keeping VGS constant, so we can get the value like this: VGS minus VT into Kn dash. So, this is nothing but the value of output conductance GD of the NMOS in the triode region. So, in this way we can see that in the triode region we can find three parameters: GD, GM and RDS. So, this is all about the operation of the NMOS transistor in the triode region. Thank you.